Okay, in this section what we want to do is work on simplifying rational expressions. And the biggest trick here is that you can't just come through and just divide stuff out that has the same factor in it. The first rule is that everything's got to be multiplying, and if groups of things are multiplying, then those groups of things can be reduced away. And so our rule is we're going to have an expression with a, b, and c. B cannot be 0 because we would be undefined, and C cannot be 0 because we would be undefined. Then we can use this property over here on the right. So, and I've already exited out, I've already factored out the C's. But notice that everything is multiplying. And once everything is multiplying, you can divide out the things that are the same. And when you do that, you're left with your answer A over B. So let's just start off with some really super basic examples, like say 15 divided by 65. Well, 15 is 3 times 5, and 65 is 13 times 5. And so once I get where everything is multiplying, I can divide out the 5's, and I'm left with 3 over 13. And that's all there is to that guy. Okay, look at the next problem. The next problem, everything is factored, everything is multiplying. I've got groups of things multiplying. And if you have groups of things multiplying, you can divide out those groups of things. And so the x plus 3's can go away. They divide out, and then I'm left with 4 over x minus 5. Okay, so not too hard on these first couple. On the bottom ones, though, on these bottom guys, it is a little bit more challenging because you have to factor everything on the top and everything on the bottom. So factoring comes back, and if you are one of those students where factoring is difficult, this could be challenging, but the factoring is important, and you need to be able to factor correctly. So what times what makes 15 that subtracts to 2? And immediately should come to mind as 5 and 3, and I want to subtract to a negative 2, so I'm going to have minus 5 plus 3. And on the bottom, x squared minus 9, that's a special, and you need to be able to recognize that that's going to be x plus 3, x minus 3. I got 2 x's down here, so let's get rid of one of those. Okay. I cannot come through here and go, these 2 x's go away, and this 9 and this 15 reduce, and that gives me, I cannot say that I have negative 2x plus 5/3. I cannot say this, okay? And this is the most common mistake that's made. You cannot do this. Factor first like I did, and then what we're going to do is once you have everything multiplying out on top and bottom, like we've got, then you can factor things out and divide out. So on the top I have x minus 5 times x plus 3. And on the bottom I have x plus 3 and x minus 3. Okay? Now since everything's multiplying, what's on the top and the bottom at the same time? My x plus 3's. And so my final answer for this guy is x minus 5 over x minus 3. That's all there is to it. Okay, just pay attention. Always factor first, and then look for items that divide out. Again, the same thing as on the previous problem. You can't come through here and go, hey, these x squareds go away, these x's go away, and then you start trying to reduce. That is not allowed. It is the most common mistake that you'll make when you factor. Don't ever do it. But what you can do is factor out a 2x on the top, and that's going to get me x plus 5. And on the bottom, you can factor this guy out. This has got to be 3x and x, and I have to get to 16 in the middle, and there's only one way to do that. It's going to be 5 and 1, and both of these are pluses. So once I have these all factored out, what I've got is 2x times x plus 5 divided by 3x plus 1 times x plus 5. And now I can divide out groups of stuff. So I'm looking for things that are the same. That's going to be my x plus 5s. They go away. And I'm left with 2x over 3x plus 1. Okay, now look at these bottom two equations. Both of them have x's on the top and on the bottom. So if you look at this, here's an x here, and here's an x here on this guy. Here's an x here, and here's an x here on this guy. You are reduced. There's nothing else to do. These x's are a part of your answer. We cannot divide them out. So you are done at this point. Okay? Once you've taken out that common factor, that group on top and bottom, and once all you're left with are things that are being added or subtracted, then you can't reduce anymore unless they're the exact same thing. Okay, on this one we're dividing rational expressions, and to divide rational expressions by each other, you have to multiply the first expression by the reciprocal of the second. So when you're looking at this stuff, our first expression is here, our second expression is here. Okay, so you're going to multiply the first guy by the reciprocal of the second. This is just how you learned to do fractions all those years ago. Don't forget that part. And then once you have done that, you've got multiplication, and you can look for things now that will factor out. Okay, so again, b and d and c cannot be 0. And then this would be what your rule looks like. So let's take a look at some examples. If I have 2/5 divided by 7/3, I could even represent 2/5 divided by 7/3 like this, which in the higher levels of math, this is typically how you will see fractions. This would be a compound fraction. And what we're going to do is we're just going to multiply by the reciprocal of the second term. So we're going to multiply by the reciprocal of that guy. First guy times the reciprocal of the second guy. So what we're going to have is 2/5 times the reciprocal of 7/3. And the reciprocal of 7/3 is 3/7. And then you just multiply straight across. And so that's going to give us 6/35. And that's the answer for that guy. Alright? On the second problem here, we're going to have 7 over x plus 1 times the reciprocal of the second guy. So that's going to be 2x minus 3 over x plus 2. So when you work out this particular guy, then what you're going to do is just multiply straight across. There's no trickeration to this at all. So what you're going to end up with then is going to be 7 times 2x minus 3 over x plus 1 times x plus 2. Okay? Not too bad. And a lot of times answers will not be given this way, factored out. So if we were going to go ahead and distribute the 7, our final answer would be 14x minus 21 over, and then if you FOIL out the bottom, x squared plus 3x plus 2. So there's those two guys. If we look at the next row, we've got we would have 7x over 2x minus 10 times x squared minus 11x plus 30 over x squared minus 6x. And what I would recommend on this guy before you do anything is that you go ahead and factor what can be factored. And if you can factor those things, it'll make the multiplication part a lot easier to work with. And so what I would recommend then is just over here on the bottom, I would just take 2 out. And this is going to give me x minus 5. On the bottom on this side, on the right, I would take out an x, which is going to give me a 1 minus, or an x minus 6. And then on the top, when that factors out, that's going to be x minus 5 times x minus 6. And so you've got these factors here that you can eliminate. And when you do that, if it's on the top and on the bottom and it's multiplying, you can factor them out. So all of these guys go away. And these x's right here are going to go away. And that's going to leave me with 7/2. On the last guy, if we divide by 3x squared plus 5x, what we don't see, which is understood, is that this is all over 1. So when we multiply by the reciprocal of that guy, we're going to have 6x squared plus x minus 15 divided by 4x squared times 1 over 3x squared plus 5x. And again, just like on the previous problem, I would factor this out as much as I could because some things may divide out. So when I factor out the top, that's going to break down to 3x and 2x. And then I want to get that 1 in the middle there. And so in order to do that, I'm going to use 5 here and 3 here. And so I need a plus, so this will be a plus and this will be a minus. And then down here on the bottom, I'm going to factor out a 3x. And that's going to get me an x plus 5. Oh, I can't factor out the 3. There's a death by 1,000 cuts move right there. I can factor out the x, and that will get me 3x plus 5. And now that everything's multiplying on the top and on the bottom, I can factor stuff out, divide stuff out. So the 3x plus 5s go away, and it doesn't look like anything else will, so I just multiply straight across. So 2x minus 3 times 1 is 2x minus 3. 4x squared times x is 4x cubed. And so these are the ways that you're going to deal with these rational expressions, dividing and multiplying. And you just have to make sure that you pay attention. The biggest key here is that you do it correctly. Don't divide stuff out until everything is factored.